So you have to have these charts memorized. So just wherever you see the 8-2A, just put it in the space above it. Let's start with this one here you see on the left. We are going to do sine, cosecant, and cotangent in this chart. We'll talk about why here in a second. So the sine starts at 0, goes to 1, then goes back to 0, then down to -1, and back at 0. Remember that the sine is on the middle line in 3 places. It goes up, then it goes down. Now, we have learned for the cosecant that every place that the sine is 0, we're going to get 1 over 0. It's going to be undefined. There are vertical asymptotes in 3 places. Now let's talk about what the cotangent is. The cotangent is cosine over sine. So it will have its vertical asymptotes in the same spots. Now let's talk about the cosecant for just a moment. The reciprocal of 1 is 1. The reciprocal of -1 is 1. So that's good. Now we haven't talked about the cotangent at pi over 2 and 3 pi over 2, since really we've done the unit circle, but both of those are 0. Now you might see that we have this repeated cycle. So unlike the sine and the cosine, a tangent and a cotangent doesn't have a period of 2 pi. It has a period of just a pi, and we're going to have to account for that when we do the chart for a tangent and a cotangent. Now let's go ahead, please, and let's fill out our second chart. Now we're going to deal with cosine. You have to remember that cosine starts at 1, goes down to 0, then all the way to -1, comes back up to 0, and then goes to 1. For a cosine, these two match, and that's your different, like, bottom value. Every place that the cosine is 0, the secant and the tangent have vertical asymptotes. Now the secant we've already learned. The secant is the reciprocal of the cosine, so it goes 1, -1, 1. But tangent is sine over cosine, so it doesn't do that. It goes sine over cosine, 0 over 1, and that's why it's 0. And then it goes 0 over -1, and then it goes 0 over 1. So you'll notice that the charts, if we just use our 0 to 2 pi, counting by pi over 2's, the cotangent and the tangent, they don't give us a lot of information. We just keep getting this vertical asymptote 0 or 0 vertical asymptote. So that's why we're going to explore what our tangent and cotangent function is going to look like. So please make sure you have those charts memorized. It's important that by the time we take a quiz next week, that you have those patterns in your head, okay? That will be part of the quiz next week. Okay, so now that we have those patterns written down, let's talk about how we graph a tangent function. Now remember, tangent is sine over cosine. And technically, the pattern for a tangent repeats in a pi. So our first place is going to be 0, but our final place is going to be pi. Now, if we talk about what we have seen in our graphing before, we need 5 points, and we still want 5 points for a tangent or a cotangent. So let's make this the halfway point. So halfway between 0 and pi is pi over 2. And then we got to cut them in half again, which would give us fourths. So this is actually going to be pi over 4 and 3 pi over 4. So for a tangent, the period is a pi, and it goes, your x's should go 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay? Now, let's take a look at what we know about the tangent. The tangent is sine over cosine. If we look at this graph paper here, here is 0. the sine is 0 and the cosine is 1. So just like our sine starts at 0, so does our tangent. It starts at 0. The tangent of pi over 4 would be square root of 2 over 2 divided by square root of 2 over 2, or from the unit circle we found that that is 1. And then pi over 2 would be here. It would be sine over cosine, and cosine is 0, so we can't have a 0 denominator, so that's a vertical asymptote. And then 3 pi over 4 is negative 1, because you get positive square root of 2 over 2 divided by negative square root of 2 over 2. And then at pi, let me show you here, here's pi. Sine over cosine would be 0 over 1, or back to 0. So the tangent gives us kind of some funky stuff happening. I'm going to show you. So our graph paper is counting actually by pi over 4s. So all we're going to do is put in 0, 1, a vertical asymptote, negative 1, 0. Okay. Now, everything is equally spaced. Their patterns repeat. And although you haven't explored it yet, this is going to be 1, and this is going to be a vertical asymptote. And this is going to be negative 1, and then 0. This is going to be negative 1, and a vertical asymptote. Tangent gives me the least useful things, it really doesn't. Positive 1, 0, negative 1, a vertical asymptote. Positive 1, 0, and okay. So those are the points that the chart give us. Not a lot of good information. But what it does is, you know how our secant and cosecant look like kind of parabola going up and a parabola going down. It's not quite a parabola. They are smushed between those vertical asymptotes. Well, what's interesting about a tangent is a tangent looks like a cubic smushed between vertical asymptotes. So it actually looks like this. So connect those points with a cubic. So sometimes even for a tangent, to get the full effect, sometimes I'll go from negative pi over 2 to positive pi over 2, because it gives me one full cubic that way. It gets me a vertical asymptote, 0, negative 1, and 1. So sometimes when I think about it, I will sometimes graph it so that I have that full thing. And the reason that it's helpful is a tangent is what's called an even function. It has y-axis symmetry. And so to get the full cubic, we need something to the left of the y-axis and something to the right. So this is sometimes helpful when graphing a tangent. So you can kind of see why we waited for the tangent to be last, because our tangent function is funky, okay? But we need to know that pattern. This pattern can also be helpful. But let's go ahead and look at some information about the graphs. So this time a period is a pi. We're going to skip all odd pi over 2. So there's a vertical asymptote at negative pi over 2 and positive pi over 2. 3 pi over 2, negative 3 pi over 2. 5 pi over 2, negative 5 pi over 2. The range is all real numbers because that cubic stretches up as high as you want and as low as you want. It is an even function. So the main thing that you want to remember is if you stuck a negative inside of a tangent, it doesn't do a darn thing. So that is some of the information about our tangent function. So far we have seen that our sine is odd, our cosine is even. Our tangent is even. The secant and the cosecant go along with the sine and the cosine. And we will explore those even and odd in the next chapter a little bit more. So if we look at this, let's just highlight some stuff, okay? Remember that A tells you if those cubics are stretched at all or possibly flipped. The BX alone, just this part, tells you the period or the repeats, where the repeats. But look what's different. In the past, we always set that equal to 2 pi. What do we have to set it to for a tangent? We have to set it to pi because the starting period is pi. So that's what we relate it to. We still get a phase shift by putting the entire parenthesis equal to 0. That hasn't changed. And this value out here is still our vertical shift or midline. Okay? So the only thing that's different for a tangent and a cotangent is to find the starting value and the ending value. Well, more the ending value. You always relate the period with pi instead of 2 pi. Everything else is exactly the same. So if we look at this example here, the stretch is related to this. You can call it an amplitude, but the stretch is 2, and there is a flip because it's negative. For the period, we're going to set that term equal to pi. So remember, sine, cosine, secant, and cosecant, we set it equal to 2 pi. For tangent and cotangent, we're going to set it equal to pi. So the period of this is pi. We're going to use this entire parenthesis to find the phase shift. We're going to set that equal to 0. And remember, that's going to be our starting place. And so we are going to get that we start at negative 2 pi. Now that's our starting. Our ending is a little different here. You set that equal to pi. Because remember, it starts at 0 and ends at pi. And so we would subtract a pi over 2 from both sides and get pi over 2. And then finally, right here is our vertical shift. So our midline is down at negative 3. So everything that we've done in the past is the same, except our period is a pi, so our ending value you set equal to a pi. Okay. So now let's go ahead and graph this one. Okay. The stretch is the number that you see right here. It's just a 2. Our period is where we set our x term equal to pi. For a tangent, you set it equal to pi. And so we're going to multiply both sides by 2. Our phase shift, so that's your period. Our phase shift, you're going to set the parentheses equal to 0, so we still get 0. Now that's our starting value on our chart. Okay. Remember, your ending value is where you set that equal to pi. So our ending value for this one ends up being 2 pi. Uh, phase shift. Um, there is none for this one because if we set that equal to 0, oh, we already did that. That's our starting value, which is 0. Sorry, I already did that. And our vertical shift is anything on the outside. There's nothing there, or we can say it's at y equals 0. Okay, so let's write down what we know about the tangent. Tangent normally starts at 0 and ends at pi. So we have the pi over 4 show up. And it goes 0, 1, vertical asymptote, negative 1, 0. So that's what it's doing. Okay. So halfway between 0 and 2 pi is pi. Halfway between those are pi over 2's. The middle one is always a vertical asymptote. Now, let's look at what we got here. The way that this is sitting, this is 2 times the old y value. It's just double the y value. So it's going to be 0, 2, negative 2, and 0. Because the only thing we have here, it's stretched out a little bit, and the heights have become 2 and negative 2. So I'm going to kind of chop up my y or x-axis the way that you see here, counting by half of a pi's, and then I'm going to make that 2 and that negative 2. So get your graph paper ready. So let's put our midline on. Now, unfortunately for a tangent, we only have one vertical asymptote, but we'll fix that in a minute. Just put your vertical asymptote on. So I only have a vertical asymptote so far at pi. Now let's put on the points we have. At 0, I'm at 0. At a half a pi, I'm at 2. So that's a half of our cubic. So this is how you fix the issue, okay? Equally space it, go the half going down, and then put in the other asymptote. So a tangent function always creates as long as there's not a phase shift, always creates a cubic going through the center. Now it's not a true cubic, but okay. And now that we see how the vertical asymptotes are spaced, let's put those on. And then let's put in all of our other cubics we can fit on our graph. So we got a value here of negative 2. So this has to be 0 and then positive 2. Negative 2, 0, and positive 2. If it's below the midline, that's going to be the part of the cubic going down. If it's above the midline, that is the part of the cubic that's going up. So you can see that a tangent graph is kind of weird. So that is our first tangent graph. I actually think tangent is probably the hardest graph. Cotangent, you get slightly nicer points to start with, so you get it's just a little nicer. That is our tangent graph. So now let's go ahead and do one more example of a tangent. So write down our 5 values we know happen for a tangent. So it's going from 0 to pi. It goes 0, 1, vertical asymptote, negative 1, 0. Okay, so once you have that written down, let's go ahead and analyze everything we have for our tangent function. So this value here gives us our stretch. Now the stretch is 2, but there is also a flip because that's negative. So instead of from center it going up 1 on the right and down 1 on the left, it's going to now go up 2 on the left and down 2 on the right. The period is just from that value. It's just equal to pi. So we didn't have a change on the x, so we don't have a change in the period. The period of a tangent is pi normally. So x equals pi, it's just pi. Now remember, phase shift is our starting place, and that is where x minus pi equals 0. Our ending spot is where x minus pi equals pi for a tangent. So in each of those, in order to get that x by itself, we want to add a pi to both sides. So here it would be a pi, and here it would be a 2 pi. So now we're ready to start our chart. We start at pi, we end at 2 pi. So the phase shift, remember, gives us our starting spot, and then just take a moment, set it equal to the period, which is pi, get your ending spot. Now let's take this chart and break it apart. In between 1 and 2 is 1.5. So 1.5 in fractions is 3/2. And then you can use your unit circle for that. And then if we count by force, now let's go to our graph paper and let's use that as a breakdown, okay? So let's make this pi. Let's make this 2 pi, because we need to see pi and 2 pi on our chart, right? So the middle value we found was 3 pi over 2. So this value here has to be, if you'll notice, we had to break down in force. Look at how we broke it down in force. Let me show you what I mean by that. It was 1, 2, 3, 4 jumps to get to pi. 1, 2, 3, 4 jumps to get to 2 pi. So this would be 5 fours. So let me show you. This would be 1 4, 2 fours, 3 fours, 4 fours, 5 fours, 6 fours, 7 fours. So, you might have to just kind of think of a roller. How would you break down a roller? So our values, this one is 5 pi over 4, and this one is 7 pi over 4. Well, think about 4 fourths, 5 fourths, 6 fourths, 7 fourths, 8 fourths. However you want to do it, but those are the x values we're going to use. Okay. Our vertical shift is right here. Our vertical shift is y equals -1, which tells me my midline is going down to -1. Okay, so let's count. So let's Let's put in all our fourth markers here. Just guesstimate where they are. Okay. Just guesstimate the best you can. Okay. Now, we do have a stretch flip of 2, so we should be okay if we just count that's 2. We just kind of count those being 2s. Okay. So get your graph paper ready for me, and then let's figure out what our y values are. Get your graph paper ready, and then we'll figure out our y's. Okay. You know that the third spot for a tangent is always a vertical asymptote. Now let's think about what we've got here. We have -2 times our old values minus 1. -2 times our old y values minus 1. Just follow order of operations. The first thing that touches it is the -2, and then we subtract 1. Follow order of operations. So it's -2 times our old minus 1. So let's do that. -2 times 0 is 0, minus 1 is -1. All of the zeros should be on the midline. All of the zeros are your midline locations. Now let's do 1. -2 times 1 is -2, minus 1 is -3. And then finally here, -2 times -1 is 2. 2 minus 1 is 1. Okay. So let's, now that we have our chart, let's go ahead and put in our graphs. So the first thing I would like to put on is my vertical asymptote. It's right here. And then I get half of a cubic. Now where's half the cubic? So let's put our midline on. There's a midline here at -1. Okay. So at pi, we are on the midline. And then we go down to -3. So that's our cubic part that's going down. Anything below the midline is our cubic going down. So equally spaced on the other side has to be the midline going up, which would be right here. And then one more spacing, 1, 2, 1, 2. Right here is a vertical asymptote. And then let's make the cubic on the other side. 7/4, we're at 1. Why? Well, that's our piece going up. And at 2 pi, we're back on the midline. See, that's a half of it. So finish the other half. Now go equally spaced and go down. And then equally spaced, there should be a vertical asymptote right here. And then here we're on the midline. Here we go up 2 to the left. Okay, so this would be a vertical asymptote. Hardest part for a tangent is finding those vertical asymptotes. So how many jumps were there between vertical asymptotes? 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4. There's another one right there. Put it on. One, 2, 3, 4. There's another one right there. Put it on. And then smack dab between the vertical asymptotes, we're always on the midline. Let me say that again. For every vertical asymptote, for every vertical asymptote, sure, right in between, right in the middle, we're always on the midline. So middle, middle, middle. See, we're always on the midline. And then this one goes up on the left. down, up, down, up, yes, down, yeah, up, down. We could even make a little. So tangents are ooky. It's just a thing. I can't tell you otherwise. Um, that's the best way I can kind of get you. You know, you could extend this chart. That might help as well. If we did it again, if we kept going, that's 5 pi over 4. And then 3 pi over 2. And then 7 pi over 4. And then 2 pi. If we did it again, is that right? Let's see. That might help because then you'll get an extension. This one is 1, vertical asymptote, -1, 0. You really want to find the vertical asymptotes. That's the tangent is, it's funky. I don't know what else to tell you. Okay, so we've got a tangent now. Let me zoom in so you can see it as good as I can get you. So if you look at the homework, there are 2 tangent functions that you'll see in the homework. There's like a tangent and a cotangent, a tangent, a cotangent. Just do the tangents that you need to turn in for 8 to C. Okay. So a thing to recognize, these are equally spaced. These are equally spaced. These are equally spaced. These are equally spaced. So, you know, you got to remember, if you keep your spacing, then you should be good to go. So if you look at the homework, it's down here. The tangent homework would be number 1 and number 4. Number 1 and number 4 is what you need to turn in for 8-2. I'm sorry, that would be 8-2A. 8-2A is the tangents. Okay, so I would start them now so that you get a sense as to what's happening, and then we'll do cotangents tomorrow. Mm-hmm.